Stop paying for slow RAG. I'm going to show you how a tiny, free, 350 million parameter model can beat a proprietary multi-billion parameter giant like GPT-4o and run nearly twice as fast. Look at this. Here is a trace from the official LangChain RAG tutorial using GPT-4o. It took 3.2 seconds to run and it cost money. Now, here is our version running 100% locally with a free Ollama model. The entire run took only 1.3 seconds and the cost is exactly zero. How did we achieve this performance with a small local model? The secret is this advanced LangGraph architecture that builds a smarter agent combined with a crucial prompt engineering trick that takes a messy answer and turns it into a perfect one. In this tutorial, I'll walk you through building this complete LangGraph RAG agent running entirely locally. We'll set up our full free stack, build every node, and assemble the entire graph. Stay until the end because I'll show you exactly how to implement the one prompt fix that gets you that perfect, fast, and free RAG response. Before we dive into the graph's architecture, it's worth noting that we've already covered the core concepts of LangGraph, like states, nodes, and type safe patterns in a previous video. If you haven't seen it, I highly recommend checking it out to get familiar with the basics. Here is a quick overview of the agent logic. An agent node decides whether to call a tool to retrieve documents or not. If it retrieves, it checks the relevance of the documents, then either generates an answer or rewrites the question if the documents were not helpful. First, set up the development environment. In the terminal, create a new Python virtual environment using OV named LangGraph RAG demo and activate it. Install Jupyter Lab and the IPython kernel. Register this environment as a Jupyter kernel so you can select it directly in the notebook. Install the required Python packages. These include LangChain, HuggingFace utilities, sentence transformers for embeddings, and LangChain Ollama. With setup complete, start the RAG pipeline by preprocessing documents. Use the web-based loader to fetch content from a few blog posts, then inspect the first document. The raw document is long, so split it into smaller chunks for effective retrieval. Use the recursive character text splitter with a chunk size of 100 characters and a 50 character overlap. Create the retriever tool. Instead of OpenAI embeddings, use a free alternative. Initialize HuggingFace embeddings with Google Embedding Gemma model and truncate the embedding dimension to 256 for speed. Build an in-memory vector store from the chunks, convert it to a retriever, and wrap it in a LangChain tool with a clear name and description so the agent knows when to use it. Test the tool with a query. It should retrieve relevant chunks about types of reward hacking. Next, build the first node, the query generator. Initialize a ChatOllama model using the lightweight Granite model. Define a function that reads the current state, binds the retriever tool, and decides whether to call the tool or respond directly. Ask, what does Lilian Wang say about types of reward hacking? This time, the output is a tool call that uses the retrieve blog posts tool with an appropriate query. Add a grader node to check document relevance. Define a pydantic schema that produces a simple yes or no score. Use a local ChatOllama model to grade. The function takes the documents and the question, formats a prompt, and returns generate answer if relevant, or rewrite question if not. Test the grader. With an irrelevant document that just says meow, it outputs rewrite question. With a relevant document, it outputs generate answer, define a rewrite prompt that asks the model to analyze the initial question, reason about the underlying intent, and produce a more specific question. Implement the rewrite question function. It reads the user message from state, formats it with the rewrite prompt, invokes the response model, and returns the improved question to update the state. Test with an irrelevant document like the output becomes, how can we better understand Lillian Wang's perspective on the various types of reward hacking? This is a more focused query that improves retrieval. Build the generate answer node. When documents pass the grader, generate the final answer using the original question and the retrieved context. Create a generate prompt that instructs the model to answer concisely in at most 3 sentences, to use the provided context, and to say it does not know if the answer is not present. Implement the generate answer function. It extracts the question and context from state, formats the prompt, and invokes the model to produce the final response. Now assemble the graph, create a state graph, and add the nodes, generate query or respond the retrieve tool node, rewrite question, and generate answer. Set the entry point from start to generate query or respond. Add a conditional edge that uses the tool's condition to decide whether to call the retriever tool or end directly. After the retrieve node, add another conditional edge that uses grade documents. If relevant, route to generate answer. If not, route to rewrite question. At the last edges, generate answer leads to end. Rewrite question loops back to generate query or respond. Compile the workflow into a runnable graph and visualize it. Run the complete Agentic RAG, stream the graph execution with a question, and print the updates from each node. In the first run, the model struggles with the initial prompt, and the model answers a question found inside the context instead of the original question. Prompt engineering is crucial. Try swapping the order so the context comes before the question. That change does not fix the behavior. Use a more robust technique. Explicitly label retrieved context and wrap the context in triple quotes with clear spacing. This creates a strong boundary and focuses the model. Run the agent again. The model now answers correctly that reward hacking can be categorized into environment or goal misspecification and reward tampering. The run completes in 1.3 seconds. So there you have it, a complete, fully local RAG agent built with LangGraph and Ollama. We proved that a lightweight model can be faster and free, but only when you use advanced agentic logic and careful prompt engineering. If you want to dive into the code yourself, I've linked the full GitHub repository and the complete Jupyter notebook down in the description. You can replicate this entire setup in minutes. If this video helped you see the power of local LLMs, please hit the like button, subscribe for more deep dives. Thanks for watching, and I'll see you in the next one.